If you're shopping for a pool enclosure in Florida, you've probably stared at two quotes that make absolutely no sense together. One contractor wants 12 grand, and another says it's going to take 25. They both look like the exact same aluminum cage on paper, so you have to wonder where that massive price gap comes from. To understand the difference, this infographic shows how you should think of a pool enclosure like an iceberg. That lower quote is almost always funding just the top 10% you actually see: the paint color, the screen mesh, and the basic architectural layout. But the other 90% below the surface is what keeps the structure standing. We're talking about wind load physics, the metallurgy of the fasteners, and strict legal compliance. That's exactly where the cheaper bids trim the fat. Saving $10,000 today can feel like a win, but it shifts focus away from the invisible engineering required to survive a storm. When a quote is that much lower than the market average, the savings are almost always extracted from the structure's long-term durability. This diagram illustrates cyclonic winds hitting a screen enclosure. The structure takes on immense dynamic wind loads, massive aerodynamic uplift, and lateral shear forces. Homeowners want a wide-open picture view without vertical posts. Cheap contractors shortcut this, simply leaving a standard, generic 4-inch beam overhead. Without upgrades, the roof sags under its own weight. When a thunderstorm rolls through, that under-engineered frame twists and collapses directly into the pool. This 3D render shows the correct engineering approach. To meet strict ASCE 722 wind load standards, you have to use continuous, massive 8 to 10-inch primary box beams and reinforced 2x10 headers. Achieving absolute rigidity under a 175-mile-per-hour wind gust takes a lot more raw aluminum and highly specialized engineering. A low-bid quote simply doesn't have the budget to buy those materials. Now let's look down at the foundation. The exact spot where the aluminum superstructure bolts into your concrete deck dictates the overarching resilience of the whole system. This split diagram compares attachment methods. On the left, cheap mechanical screws rely entirely on friction, cutting threads and causing microfractures. Wind vibrations transfer down to the screw, widening these fractures. Water fills the gaps, causing concrete to spall and rebar to rust. The premium standard is advanced chemical anchorage. It involves cleaning out the drill hole and injecting a high-performance 2-part resin before the anchor goes in. Looking at the right side of this diagram, the resin expands and cures. It forms a waterproof seal, blocking chlorine and salt moisture from the metal. While mechanical screws suffer catastrophic pullout, this chemical bond is frequently stronger than the base concrete itself. Chemical anchoring takes more time and costs more upfront, but it physically fuses your enclosure and your deck together into a single, unshakable unit. There's another hidden trap in the hardware itself. If you put a standard carbon steel screw in direct contact with an aluminum frame near the salty Florida coast, you create an electrochemical reaction. This comparison shows dielectric dissimilarity. The two mismatched metals act like a battery, causing the cheaper steel screw on the left to corrode rapidly. As the steel rusts, expanding iron oxide exerts immense outward pressure, causing stress fractures until the fastener loses all holding power. The bottom half of this diagram shows how premium installations handle this. They use marine-grade 316 stainless steel, paired with proprietary polymer head fasteners, like the Nilotech system shown here, to physically and electrically isolate the metals. Upgrading your fasteners is the only reliable way to break that electrical circuit. It keeps ugly orange rust stains off your white aluminum and, more importantly, prevents a systemic structural collapse. Where the pool cage meets your home's roofline is arguably the most vulnerable spot for water damage. This diagram points out the 5-inch flaw. Attaching the cage directly to the fascia using standard residential gutters means a heavy Florida downpour will quickly overwhelm them. Water overflows and backs up directly into wooden soffits, leading to hidden, severe wood rot and termite infestations. The cross-section on the right shows proper hydrological management. A heavy-duty 7-inch super gutter acts as a load-bearing structural bridge, physically isolating the wet aluminum cage from the home's organic wood. Its massive volumetric capacity safely channels the roof cascade away from the foundation.
Moving to screen material, this infographic breaks down lifespan economics. Standard fiberglass quickly turns brittle and tears under intense UV radiation. Looking at the 10-year cost of ownership, investing in advanced marine-grade polyester extends the lifespan to 15 years, bypassing massive rescreening labor costs. When you look at the total life cycle, the higher initial quote is doing the heavy lifting to protect your home's roofline and drastically cut down your long-term maintenance bills. Beyond the physical materials, there is a massive legal risk hidden in the lowest bids. Unlicensed contractors, often called trunk slammers, will sometimes offer a cheap price but ask you to pull an owner-builder permit to get the job started. This flowchart outlines how that tactic works. By Florida law, pulling the permit yourself instantly transfers 100% of the liability from the contractor directly to you. If a worker gets injured or an inspector finds major code violations, you pay the price. You absorb all the legal danger for a structure that was already under-engineered to begin with. The cheapest quote on the market might make sense for a short-term property flip, but if you plan to live in this house and weather the next major storm, you need a structure built to survive. ASCE wind load compliance, chemical anchors, and marine-grade steel provide the physical integrity needed to withstand a high wind hazard zone. These specific engineering choices are the baseline requirements for a safe, permanent extension of your home. To get a site-specific, engineering-based consultation for your property, check the link in the description to connect with the team at Screen Factory Florida.